Okay, I guess we're gonna get started. Hello, everyone. My name is Sako. Today I'm gonna talk about building well architecture infrastructure in public cloud. And I am based in US, California, and working as a DevOps security engineer at the late stage startup called Gladly. And let's see. Today in agenda, we have very packed actually agenda. Last minute, I was pushing for the slides. So we will probably roughly have 45 minutes deck. Just we'll try to cover as much as mostly the concept and a couple tools right now widely used across the early stage and late stage companies. And if we get time for Q&A session, and then we will do the wrap up. So that being said, let's begin. Just to check in, let me see. Okay. So we're gonna start with, so let's say if you have the idea, 1 second, I'm gonna just make sure. So let's say you have the idea, and first and most thing what you are gonna do, so you're gonna make sure that while planning the product and process and bringing people, and make sure that that's something customer wants. Usually the customer wants something cheap, fast, and high quality. But then there are other things that customer expects, but they don't mean it directly, which are the non-functional requirements of the application, which is performance, scalability, reliability, performance, and security. And if it translated to the app stack, then this is mostly taken care of by the architecture and your infrastructure, which is sitting underline of your application, which mostly has compute, data, and network, which is, it can be on-premise or it can be in any public clouds like AWS or GCP. So now we have from idea to the path till the stack architecture. Now, let's see. Today, we're gonna cover mostly cloud applications, which is cloud native, we call them. And before that, let's look at what are the options we have in the public cloud. So we have three types: infrastructure as a service, or platform as a service, or software as a service. So mostly the infrastructure as a service is like, we can give example from AWS cloud is like EC2 instance, for example, or in GCP compute instance, which is pretty much you have full control for the underlying operating system. So you can upgrade, delete, add package, and so forth. You have that level of control, but you don't have control for the hardware side of that. So when it comes to platform as a service, you have the operating system is taken care of, but you still have to manage, like you can add your application and the libraries. So that being said, but software as a service, in other hand, is purely giving you software as a service. So you can, let's say, if you are getting some subscription-based software as a customer, or B2B, or you are paying for some APIs, that's software as a service. And three types of the cloud: public, private, and hybrid. Public, we can give as example AWS, GCP, Azure. This is all public cloud providers. And for the private, it's usually like on-prem. If you have your own data center, you call them private. And hybrid, if you have mix of private and public cloud or data center. Okay, so what are the cloud native SaaS apps? Cloud native apps called microservices, which is now a thing in software development where you have like the application development styles. There used to be most popular the monolith applications where you're putting all the logic all in one, the code base in one business, all the business logic, while now with microservices, it's separate and into smaller pieces or more modular application. And so the characteristic of the cloud native application usually you can access from anywhere. It requires zero trust. Zero trust means there is no any perimeter infrastructure, so no VPN and nothing. You need to verify their identity and then let them in, use the applications. So for SaaS apps architecture models, you see there are three types: silo, pool, bridge. What they are, so for example, if you're using your dedicated resources for your application, let's say if you are leasing machine, let's say, and that's only all the compute or all the memory and CPU belongs to you. This is a silo. The pool, it means the underlying thing is a multi-tenant application, which means it's shared across these different people or the customers. These as customers. Bridge is hybrid mode where you have dedicated and shared resources. Okay, now let's look at the software development stages. So software development usually start with requirement solicitation, where you are gathering the requirement. It can be any stakeholders, or it can be any potential customer, or it can be a different team. And once you get the requirement gathered for the problem you're trying to solve, you sit and usually design the application without starting the code. So the main thing in that stage is, when it comes to cloud native applications, how you can make it stateless and immutable. Stateless means you can horizontally scale. So there is no anything like, for example, stateful applications. If you have any database and storage, and when if you need to scale, you need to take care of because it's sitting in your file system. But stateless applications, they're purely they decouple the data from the compute, which means that you can scale as much as you want the compute side of the application. And immutable, usually especially it's used in containerized environment, where you cannot, once you run your container, you cannot modify and do any changes in the file system of container. For example, they are read-only. So, and the next step is the development, where you are writing a clean code. The two key metrics you have is time efficient and space efficient. It's similar to like time and space complexity. So that's if you have decent CS degree, I think that's you're probably gonna do a good job on that, and which means you will also save your cloud infrastructure or any other infrastructure cost as well, because it will require less compute, less data storage, and it will be more, and it will solve the problem more efficiently. Can you hear my? Hello? Okay. Let me quickly check in. Okay, so hopefully my voice is coming normal. And the next step is a testing stage where you verify and validate before deploying to production. So usually also you develop and you deploy to development and staging, and then it goes to production. And the key thing in the testing stage, you are trying to improve the code quality, because once it's shipped, it's becoming more expensive to fix the bug, and also it's bad for the company reputation, and especially if there is any security bug and so forth, it may cause a lot of other types of troubles. So next step is the deployment. Once you developed and built the code and you tested and everything looking good, then you pushed also to registry, or let's say container registry if you are using microservice containerized application. And once you deploy, there is two things you need to take care of, which is make sure you don't impact running application and not introduce any new bugs. And usually also key metrics, how you can, if you are targeting to continuously improve your CI/CD pipeline, you need to make sure, okay, how I can release fast and frequently. That's in that stage, that's one of the questions you ask yourself. Okay, so next step is design patterns. Hey, Linda, can you hear me?
Yes, currently.
And see the screen? Okay.
Yes, very well.
Yeah, awesome. So when it comes to design patterns, usually it's industry problems which already was solved, and you are trying to solve similar problems. So the idea is here, you take it and customize and extend it usually, and apply to your problem. So there are a lot of design patterns in industry, and that's usually the way you start. You don't start from the scratch. You don't reinvent the wheel. Okay, so what are the things you don't do when you are using the design pattern? So you have to keep in mind, it's not coding. So it's before the coding. So it starts, and you shouldn't reinvent the wheel, what it says, and check more or more relevant pattern for your use case and try to apply it. So there could be sometimes there are fitting multiple design patterns, which in that case you try to modularize your application and use different design patterns in your application. Okay, now when it comes to selecting the software, which means a lot of time we use any open source project or we use open source libraries, and we usually label them because there are so many also open source software which is no longer maintained and so forth. So that's why there are some of them, they just getting started, which is we call them emerging. They may be promising, but they may not have a community around. They may be just single-handed or some company behind which could later stop maintaining and so forth. So it's a bit risky. It's better to wait a bit of time to community and more people and it get more adoption and then use them. So which is coming to the second point, which is recommended, usually which widely adopted, and there are a lot of companies backing them, big companies like one of them like Google, for example, Facebook, they are quite active in some project like, let's say, Kubernetes and so forth. So the next one is Allot. You can still use them, for example, but then they may have some drawbacks, let's say scale and so forth. which you may hit late at later stage in your software development. So it's still a lot, but it's not really recommended. And depreciated, rejected in these categories, if you have anything using, it's fine, you can use, but if it's rejected, probably there is any strong reason that this is some security bug or something which you have to avoid. So it could be part of the company security policies you have to follow. Okay, so now let's slowly talk about a couple tools. In general, version control systems are there for tracking and managing changes to the software code. And one of the most popular one, which is started by Linux Torvalds, is Git. So Git is CLI tool, and you can have your own code base copy in your local, and you can have in the cloud, which in this case in GitHub, which is taking care of that for you, and which enables also collaboration and across your team to develop and store your code base. There are other similar services as well, GitLab, which you can also host the server if you wanna in your infrastructure. So when it comes to developing, how usually the development happens, you don't push to the main branch. You create your own branch, making changes, you test out the changes, and once you feel they're ready, and you are creating a pull request. That's also same in the any open source project. So you cannot go directly push to the code base. It has to be reviewed and pass all the testings and so forth. So that being said, a couple Git good practices. It's a code base. It means you have to store the code. You cannot store like big, let's say, artifacts like videos, pictures, and so forth, and because it's gonna slow down, and there you can hit some limits as well. Use Sherlock clones for CI, which means you don't have to every time go and pull your Git repository in your CI system. That's one of the best practices, and which is it will go only snapshot the current branch. It will not take the snapshot of other branches as well. So caching, it's better. It's recommended to use the caching in the build agents, and choose your triggers wisely, which means you have to be smarter around like when should you, every time you have a commit in your branch, should you create a new image and so forth, which you shouldn't do. And when it comes to polling and versus hooking, so again, you should make sure that in your CI system, you are just pulling the changes, not every time instead of cloning from the repository. Okay, so now let's talk about the GitOps principle. What's GitOps? GitOps became famous in recent years. It's the way how you can build and deploy your application instead of sorry. Hello? Okay. So this is, it used to be the push mechanism where like you were developing your software and pushing it to the production. But now with Argo CD projects like Argo CD, we can also see a little later, it's switched to the pull mechanism where GitOps principle says, you your application desired state you store in Git, for example, in your code base, which is versioned and immutable. And once you push the new changes to your application manifest and change the image version, for example, and so forth, Argo CD will go and pull that changes from your code base and deploy. So instead of pushing from the code base to the your cluster and deploy it, for example, Jenkins and so forth, which is technically you have to trigger and push it to production, the changes. Instead, Argo CD will continuously monitor and will push, will pull the latest changes and deploy to the production, to the cluster. And before moving forward, it will be nice if you have any questions, please feel free also write in chat. Semantic versioning, briefly touching that would be helpful, because across industry, there is a thing called dependency hell, where if you don't manage rightly, you may have a lot of breaking changes which may impact your reliability. So what's semantic versioning? Semantic versioning has a major, minor patch. You can see versioning number, and any software, any changes you make, you have to follow that rule. So for example, if you have any breaking changes, you have to make the upgrade the major version and put in your changelog, and because whoever gonna use your software, they have to be aware of that change and do the required changes if they need in their side. So minor, if you have any bug fixes and so forth, you can do in the minor, which or adding new feature which won't fix any, which won't impact your application, and the patch if you are fixing bug and so forth. Okay, so now let's come to CI, continuous integration, which is in development stage. So the best practices here, we have like how you can commit early and commit often, and keep the build screen, which means you should make sure that the number of failing builds, it's more robust, yes, you have, and just build only once. It means you shouldn't, for every commit, for example, kick and build, because it's also going to be expensive and it's going to impact the performance. And the testing strategy and how you're approaching that is important. Like, are you having like flaky tests and so forth? So the setting environment, like cleaning after the build, is also important, because like you don't want to you want to have as much as reproducible, repeatable builds to have. Test-driven development, which is means usually before starting the coding, you write the test cases based on what you should input and what should output, and then you develop the logic, the code around that. So there is also domain-driven development, which is also more coming understanding from the having a domain knowledge that how you are solving the problems, and then based on that, for example, naming components and so forth. Pull requests and code reviews, obviously, that's one of the key things that you still need a manual code review, and optimize pipeline speed, which is important again, because if you have low performance CI system, probably people will try to just use mostly the local system, and it will slow your application development. And That being said, let's now go to the testing. So there are a lot of various testing used, and testing, it's a key contribution to the product quality, having less bugs and less defects, I would say. And if you see acceptance testing, usually it's UAT, which is usually user acceptance testing, and we have also integration testing to test the compatibility between the different software components. Unit testing is usually, it comes down to unit, each smallest function testing in your code base. Functional testing, it's mostly the user functionality testing, and for example, what's a user, your main customer flows and use cases, and you go and test that, make sure it's working as expected. Performance, stress testing, regression testing, they're all related to how your application will behave under 10x load, for example, and will it be slow, or with the new release, because usually the end-to-end user experience is under the budget for the delay is 200 milliseconds. You have to always measure that. For example, if you have a website, when you're opening, it should not take more than 200 milliseconds. So if it takes, it means you have a problem, and you have to investigate. So usability testing, again, you have to, there is accessibility, usability, and all these testings, which is validating that that's what really customer wanted. So now let's come to continuous deployment strategy. So once you build and tested your software, the next step is now you're going to need to deploy your software. And there are multiple strategies for that. Rolling means it's going to do rolling update. For example, if you have 3 replicas of your application, it's going to delete one of them and bring a new one, and then do the second, and so it's going to do it more smoothly. Blue-green deployment, in other side, you run side by side 2 versions of your application, and then once it's fully ready, you just switch it, offload the traffic from, let's say, blue to green or A to B deploying. And canary releases, usually you route a smaller portion of your traffic to the new release of your application. So the create strategy, which is you just delete and create, which is more disruptive deployment, I would say. Again, if you have any questions, please feel free to write on the chat. Otherwise, I will continue. And let's talk about the data metrics. So usually, there are a lot of metrics that in the DevOps team, there are a lot of dashboards that DevOps team have to take care of. But one of the key one that Google research team came that is after 5-6 years after their research, they came up with these 4 metrics for the DevOps team, and that should take care of, which is, first one is deployment frequency of software releases. So the question, can you ship weekly or daily? So a lot of companies now either ship weekly or bi-weekly, they have releases. So, but some companies is a mature process, and build and in place. They do it, for example, a couple times a day. So that's not usual. Second metric is lead time for changes. So once you make a change, and what's the time required the code to go to the production? So usually VCI, which requires the master, the main branch, to be always deployable. So it means how much time will take for you to make a change, to push your branch, create a pull request, and it to be merged to the master. So, and then there is, again, usually also in most of the companies, once it's deployed, you push and merge your changes in the main branch, it's getting first deployed to the lower environments like non-production, and then once tested, it getting promoted to the production environment. So that's a time is key. That smaller that time window, more in better shape your DevOps team. And meantime to recovery, if you hit any issues and how much time it will take to recover or to roll back the application. That's saying, and change failure rate and how frequently you are having that kind of problems versus successful deployment. So this is these 4 DORA metrics, and these are key metrics for the DevOps team. And now let's talk about scalability. Scalability, in general, it means how you can make your infrastructure more elastic, means it can, based on if you have more customer coming to visiting your website and so forth, it can scale up, and how it can scale down your infrastructure, and which obviously will make sense. It can save your cost. At the same time, if once it hits a lot of custom come, it can still serve the request, which means you can also make more money at the same time. So usually in infrastructure terms, there are a couple, but 2 are vertical scaling, which means, let's say if you have if you're hitting your server limits, memory, storage, and CPU, you go and change the node type. So you change the node to different type, and your application will be able to use more memory and so forth. But which is not scalable because you can still hit that limit for the single instance, and but in other side, for horizontal scaling, you don't have that limit, so you can just add as many as instances and scale your application horizontally, which is more healthier growth scale. So now let's talk about the reliability. Reliability is one of the thing, like at a given time, will it work as expected? So serviceability is similar to maintainability, which is how simple, how easy, how fast to fix if there is an issue in your application. So availability is more about whenever the customer or service is getting used, it's operational, it works. So that's kind of, usually it's measured in industry with SLA, service level agreement. So if you see 99.59, and that is SLA, which usually this SLA can reach 100%, which is normal because we have to assume that things will always break. And what we can do, we can just minimize it as much as to 5 nines and so forth, and to close to ideal state. So Now let's also briefly mention about failover. So that is, if let's say you have some operational application running and or the database, let's say, as part of the disaster recovery or geo-redundancy, you can have a backup of your system and running in somewhere else. And whenever there is an issue, you can reroute your traffic to that instance, which is, for example, it will depend on how fresh backup and so forth, but you may lose the data in that time window when you are switching your traffic. Warm standby is a bit better in a way that it will continuously talk to your active, let's say, database instance and pull the changes. So, but you will still lose less, but still some amount of data. And another one is hot standby, which is active. Let's say if you have a couple instances of your database, they will be in active mode, and they will just, if one of them is down, the other one will take off the traffic, and the application won't be impacted much. So now let's briefly mention about chaos engineering. Chaos engineering is it in a way like it's experimentation of how robust your application or infrastructure. And usually there are 3 steps. First, you have to plan an experiment and choose some use case or scenarios where you're gonna do it, and then you can execute and just see how your system behaves. So you can do in production, but it's better to do it in lower environments first and get better understanding and have a playbook in place, and then just follow that and deal with that. So when it comes to security, usually there are 3 things: confidentiality, integrity, and availability. You have to take care of these 3 things. But beside that, when it comes to infrastructure and your software, there is, I think, for the compliance, if you want to be PCI compliant or SOC 2 or FedRAMP, NIST compliant, and because that's kind of you need to go over and have a security controls in place where you regularly do, and these auditors, when they come, and you just pair up and you provide that evidence that you have done the compliance gatherings and you follow that security policies and rules in place, and that helps you to be more secure. At the same time, it gives you more trust when you go to acquire customers, because some industries also heavily regulated, and they really expect you to be compliant depending on the industry. So when it comes to infrastructure, mostly infrastructure security is about, like, if you are in public cloud and the services you usually use, they have pretty much decent featured, but you have to just enable and do some security features hardening, and just make sure that the application, once you're developing, and while they're still in your code base, you do static security analysis, and or while the testing, once you run your application, you can do black box testing, and periodically, also quarterly, let's say, you can hire independent pen test team and let them do it. If you are a small team, you cannot afford, that would be the recommended way to go. Other than that, there is a data security, which usually we talk about rest transit compute. What does it mean? While you are processing the data, how secure is that? And if, let's say, if somebody steals the data, can they do something about it? Or it's rest? Have you enabled any default encryption? For example, if you have S3 bucket in AWS, have you enabled default encryption for your bucket? Or transit, when you are moving data around, how secure is that? Which is usually, are you using HTTPS or TLS and so forth? This is the data security. Okay, when it comes to audit, you obviously use a lot of tools. For example, one of them, we will also briefly mention if you get time, Teleport security audit for the access management. So once you should be able to answer if there was any security incident happened, what happened, when happened, who did what and where, and all these logs. So that's audits. Usually also you put in separate isolated cloud account where only few people have access. It's heavily also monitored, and then you push all these logs and so forth related to that place, in case if you get compromised, that this account will still be able to get hacked. Yeah. So okay, now let's talk about observability. So in DevOps and infrastructure term, the observability comes down to logs, traces, and metrics, and by aggregating all the metrics from these data sources, and you can have this visibility in your infrastructure. Okay, now let's, if you have any questions, I see Stella and Talika. If you have any questions, feel free to write on the chat. Otherwise, let's talk about Golden Pass. So what's Golden Pass? Golden Pass is a reference architecture where you don't have to start from scratch. You take that base. For example, there is a Git repository template or pipeline reference, and for the, if you have like Helm chart reference, which you can use in your application, and which you have also built-in observability, logs, traces, metrics, and alerts. So this helps you to speed up your new service development flow. And a lot of companies have that kind of reference, let's say, documentation, repository code, their code base, and they provide the training and so forth, for especially for new people, new employees onboarding. It helps them speed up, make them more productive. And in our case, here is example Golden Pass architecture. So if you can see, we have, we can talk about each one briefly as well. I think we still should be good for the time. And we have underlying like Kubernetes sitting, orchestration, and we have here observability, logging, tracing, all these tools. And then we have CI/CD, which is GitHub Actions, and Harbor we have image registry, and here we have CD, which is Argo CD in our case. And we use also Teleport for access management. So let's say this could be our Golden Pass architecture that once we start developing the application, we will have all these manifest and all this flow in place. We will just add our make it changes and customize for our, let's say, applications Docker file, a Helm file, and so forth, and then deploy, and whole stack should just do the work for our application. Okay, now let's talk about a bit tooling mentioned. Infrastructure as a code, it's declarative approach for defining infrastructure and architecture. So the most famous one is Terraform, now Pulumi and others also picking up. But the key idea is there used to be a lot of infrastructure which was doing a lot of manual work, and then over time it was adding more resources, and so it was becoming harder and harder to maintain this knowledge somewhere. So that's how Terraform was born, that how we can keep all these infrastructure changes and make it also reusable across our stack. And that's how Terraform was born, and how we can make our also infrastructure development more faster and more efficiently. And second one is Kubernetes. Probably you already heard. Hello, Isaac. Feel free if you have any questions, write in the chat. So Kubernetes was the tool was born back in 2014. Google was using for a while the technology called Borg for the internal systems, and what they did, they open sourced Kubernetes, and it was well adapted across industry. I think at this point, a lot of companies are using, especially if they are also in cloud, or even the old companies, legacy companies also moving to Kubernetes. It was battle tested, and there is no doubt around that. So what it's doing mostly, if you have your application containerized and running, and it will just take care of deploy and run your container application. So it's doing a lot of thing under hood, so you don't have to do it. For example, if your application is stuck, it will just restart and so forth. So, or the network layer, you don't have to go assign IPs and so forth. It's all taken care of by Kubernetes. So even the scaling, which we talked earlier, there is node scaler, vertical and horizontal scaling, which Kubernetes enable based on, for example, number of requests. If, let's say, your website is getting 10x requests, it will be able to, in infrastructure layer, scale your application, and your users won't experience any impact. So the next one is service mesh, which is came after Kubernetes, was developed in joint effort with Lyft, IBM, and Google. So this is a control plane for your Kubernetes cluster, which is doing mostly, it's doing three things: observability, security, and networking, like intelligent routing and so forth. So because there was a lot of integration needed for the application to do, which this project said, hey, why not just to create one container in front of your application container and put all this logic there that your application will stay clean. And that worked out. So it's called sidecar. So it's injecting a sidecar in front of your application container, which is doing all these amazing things. Like for observability, you can have like tracing and so forth, which otherwise you wouldn't have, or MTLS, let's say mutual TLS, which is when your service talks to the service inside your cluster, it makes it secure this communication. So that's what one of the things Istio enables, service mesh. Yeah, so which already mentioned for the Istio. There are other service mesh technologies and Linkerd and so forth. So, but this one probably one of the most promising and strong one which started. But again, there are Linkerd and they're still coming. And feel free to go and play. I think now also eBPF project is picking up, which is more like how you can do without even sidecar in host level to do some of these things. So Meshly is the project I was part of also as a Google Summer of Code back, and Lee Kalkudi is amazing community leader and creator of this project. So what the project does mostly, all these service meshes, it's doing the benchmarking and testing, the conformance testing, and evaluating for different your stack that how these different service mesh technologies gonna behave. So okay, Harbor is one of another SNCF open source project. It's mostly what it's doing, it's image and your chart, Helm chart registry, where it's just storage. So you can ask if you have Docker Hub and or ECR from AWS or GCR from Google, why we still need. So if you want to have more control or do image scanning, which all these things Harbor enables and give you more control and who can access and so forth. And it's free. If you host it in your cluster, you can just use it. So let's say if you have a lot of customers and you don't want to give them access to your Docker registry, you can use install Harbor and just mirror from your Docker Hub to Harbor, and then they can pull the images from there, for example. That could be the use case. Argo CD is one also which brought it with itself GitOps principle. So it's which we already talked, like in continuous deployment phase, it can be used. So it's heavily adapted for the heavily built around Kubernetes environment. So if you have your application in Kubernetes, definitely you should check out the project. So the way it works, again, you submit the code to your GitHub, and if you have as a CI GitHub action, it will just trigger the pipeline and will build the image and push to Harbor. And once it pushed to the Harbor and Kubernetes manifest, for example, if you have Argo image updated, it will update the manifest, and Argo CD will go pull and deploy it to development staging and till production. So Argo CD, and there is for a bit advanced use cases, there is also Argo rollout, which is still under Argo project. So Argo CD, Argo rollout, Argo image updated. With these three projects, you can have a really nice continuous deployment for the application. Teleport, which I am also going to speak in the conference tomorrow, which is back-to-back. So another amazing open source plus enterprise tool, which is handling your access management to your Kubernetes cluster or your application, which means you don't need VPN, or your database, which is, let's say if you have Postgres in cloud running or you're in a cluster. So and you don't want to have a VPN or direct access, you can enable through the teleport and or your servers, let's say your clusters or any instances you have in cloud. If you want to enable SSH access, teleport will take care of that. So the philosophy behind Teleport that they saying that secrets are dangerous and there should be zero trust, no perimeters for your application, which means it should be identity-based authentication and authorization. So that's the logic behind Teleport. And Helm, which we briefly mentioned, that for your application manifest, which you can use just Kubernetes manifest or templating like Helm or customize. So there are these kind of similar templating languages, which is in YAML format that you can use and define your application manifest, and you can install and upgrade to your application. So there is also a project called Helm File, which is what it's doing. It's also templating on top of Helm, which is also doing some nice things if you want to check out. And if you want to be single click of button, bring all your application stack, that's probably the project you want to also check out. Prometheus, it's also widely adopted monitoring system. What it does, simply collect the metrics from your, let's say, Kubernetes cluster, from the host, container, your application logs, and so forth. And you can have some rule expressions, rule base, and then it will show you. And it can also trigger some alerts based on that. So it's pretty much monitoring system observability for your infrastructure and application. So another project is Grafana, which is mostly focusing on the UI visualization side. Let's say you can connect Prometheus and Grafana. For the Grafana data source could be the Prometheus, and what's gonna do is it's just gonna show the metrics for you in a nicely, and any logging logs, and gonna do some alerting if you want to do, like, if you can also integrate with the tools like PagerDuty and so forth. So that's what Grafana is gonna do. So there is OpenTelemetry thing called, and which two projects came out of it, Jaeger and Zipkin, which is pretty much distributed tracing. Because there are so many, once somebody visiting your website, let's say if you have couple microservices running, and if there is any issue, it's becoming so much harder to debug where is the problem is coming and so forth, root cause analysis, where or even how much time it takes, let's say from one service to another, from that service to another service. So, or if it's request going out to calling external API and pulling some data and so forth. So this tracing helps to trace whole flow from beginning till end and see where you have the delay, and see the details, what's in the request headers, sending, what's getting response, and how much time it takes. So pretty much it helps you a lot for debugging any issue, or just in general, if you want to understand, like for the security incident, for example, if it's making API call to any external services, it shouldn't, so for example. So this can help you. Okay, oh my God, 6:02 for me, which just in time. And I wanted to now give some small task to you. I see 5+2. So if you wanna write in the chat, I can give you a minute, and then I will also go over each question and just briefly mention. I think it's gonna be interesting for you. Yeah, my pleasure, Talika. Yeah, feel free to spend some time, and I can also start mentioning, because I will try also to pass the slides, and hopefully if you missed you can go and check. And if you have any question, you can also ask later. Now, this is the last slide. Probably I'm gonna also just mention a few things. So, for example, operational excellence when it comes. So this is referred from AWS, well-architectured frameworks they call infrastructure. So how support development and run workload effectively. So it's mostly about the process. So you should have scalable and process for your designing development. So pretty much you should have a good playbooks that anybody can come and do it. So any task in your application or infrastructure should be delegatable, distributable, and the bar should be lower. Also, somebody who joined recently your team, that they should just go with less questions and do it and get the same result if you go and do it. So that's kind of operational excellence you should target. When it comes to security, we already went over. So infrastructure, application, data security, that's kind of, if you start, you look from these three things, and then you go to nitty-gritty details. Like shifting left is a new term now also in the security, like how you can find the security bugs and so forth earlier in your development stage rather than after shipping to production, and you go realize, oh my God, we have that CV and so forth. So reliability is about making sure that you function correctly and consistently when it's expected to. So for the reliability, what you do, you can do in your application, but it's also a lot depend on your infrastructure, how to make it more fault tolerant. So you can also even sometimes inject the fault house in engineering, which we mentioned, that can help you to improve your reliability and how to make it more robust. So if, let's say, one of the components in your application stack won't work, how you can bring down the blast radius of impact that other components still can function and so forth. So this comes down to reliability, that it won't impact the availability of your whole stack. So when it comes to performance, how you can to use computing is efficient to meet system requirements. So again, this is more like also comes to clean code, which we mentioned, and how you can make space and time complexity of your code decent, that it will not have any memory leaks and so forth, and you will have a decent performance. It also depends on the, let's say, still compute instance size or the in and out network bandwidth you have and so forth, or if you have database IOPS and so forth. But the main thing is coming to how you can keep your application like more SNCF native and more lighter. For example, also picking the language matters. So if you have a heavy JVM application, it will consume a lot of resources. But if you have, let's say, more lighter application written in Go or Rust, will probably be higher performance. So if you have something written in Python, which will be trade-off again, it won't have much performance, but it can still be less lighter running. So, and when it comes to the cost piece, the key metric is to deliver business value at the lower price point. So one of the things also, if you go to funding and so forth, your if you are a software company, that's one of the investors' questions asking, like, what's a percentage for dollar amount you are getting as a revenue? So let's say if you are earning $1, how much of that, what's percentage going to your infrastructure cost? Because that can be over time quite expensive. So if you don't track it early in your company, it can quite hit harder later, and it may be also more expensive to redo it. So I tried to cover each one briefly, these 5 questions. Hopefully, it helped to give you some understanding. I'm not sure where the folks are, the background coming from, but I try as much also keep like minimum less terms, like more focus on the concept side, principles, rather than going deep into the specific technology and so forth. But if you have any questions, feel free now or later again to shoot me. That being said, this is me. Feel free to add me in LinkedIn or connect or Twitter, and happy to connect and help. So again, I am Sako. I'm here based in Silicon Valley, Bay Area, California, US, and working in startup called Gladly. And on the side, I'm running also community called GoUp, more focusing on the open source projects. And so that's my side gig doing. So and these slides and everything probably I'm gonna put on that. So which is, I'm gonna also put in, still not ready, but the slides will be there. Or if you don't get it, feel free to connect to organizers. Probably they will be able to teach me. So again, it's your call. I try to as much as to give you all the context details here I could. That being said, oh, Tali, that's great. I'm glad to hear. Yeah, for a couple nights, I was just working on the slide because I have again 2 back-to-back, one more also teleport presentation, which will be in San Francisco here in person. So I still have to work on that, but I prioritize also this talk, and hopefully also that one will be good. And you can also check the recording probably if any interest. So again, thank you so much, all the folks. Have a nice day. And for me, it's 6 a.m. It's time to get some sleep. Thank you so much. I will stop sharing.